Hello and welcome to the 5th edition of the Cloud Native Talks. The title of today's presentation is Kubernetes, Logging Techniques with a Touch of LogSense, presented by Marcin Stożek. This event will proceed as follows: a short introduction, the main presentation, and finally a Q&A session. Please post your questions in the chat. Marcin will try to answer them during the presentation. My name is Eliza Kasperuk, and I'll be your host for this event. Our speaker is Marcin Stożek, a software developer and DevOps by day, and a hacker news addict by night. Please note the following upcoming events. During summer, we plan to organize more Cloud Native Talks. The next talk will be on the 25th of July. We will post more information soon, so stay tuned and follow the Cloud Native and Kubernetes community on social media. All links are in the description below to the video. You can buy tickets to the Cloud Native Conference, which will be on the 9th and 10th of September. There are workshops alongside the conference where you can learn Kubernetes and Go. But today we have a treat for you. Thanks to the generosity of our sponsors, we have 50 tickets to the conference with a 50% discount. They are meant for our community, and you can find the special discount code in the description below the video. So be fast and use the code as fast as you can, because it's only 50 tickets. And now, welcome Marcin.
Hello everyone. Hello. Can you hear me? I guess yes. Hi, my name is Marcin Stożek. I work at LogSense. I work with Kubernetes, and I'm going to tell you a little bit about the Kubernetes logging techniques, about how to log things from your Kubernetes cluster. Let's start with a little bit of a story. How do we log things at all? If we have a simple application which just log things, it can do it on the three possible ways. It can log into the local file, just stream output into the file, and that's it. It could stream the output of the logs into some remote location using libraries or some other techniques. Or it could just stream the logs output into the standard output and standard error, and that's it. And one of these possibilities is, in my opinion, better than the others. Of course, all of them have use cases, but I'd strongly agree. I'd strongly say that one of them is my preferred choice, and the one of them, and the one I'm talking about is the standard output and standard error logging. And why is that? That is because if we log things into the standard error and standard output, we don't take the responsibility of how logs are stored and where are stored and so on. This is up to the system administrator or the guy that is using our application, and because our application is one of maybe many applications, and because of that, we as a developer, I just want to log my files somewhere, but as a system administrator, I want to see all of the logs logging using the same structure, for example, or into the same place at the server, so that I don't need to look, in all of the different places to look for logs. And with this, it's easier. If we just log into the standard output and standard error, we just give administration, the administration people power to use their preferred logging techniques. This is 12-factor application compliant. 12-factor app is a standard which tells you how to write applications that are both manageable and both sides, developers and administrators, can talk to each other using this 12-factor app standard, and they have this middle ground on how the application should behave. And one of the things about one of the behaviors of the application is this logging. There is a problem, though, with this standard output and standard error logging, and the problem is multi-line unstructured logs. That means if I use some libraries and just put my logs into the remote location, or even not remote, maybe local location, but using libraries, the libraries know if my log was multi-line or it was single line. And if I log into the standard output, I just have lines in file. That means I don't have multi-line logs anymore. I just have multiple lines of my logs. And that might be a problem when, for example, I want to see the logs or the Java stack trace, which we all know are multi-line and not single line. And if I have this as a single line logs, then I just don't have the structure which tells me this is one single Java stack trace. I just have multiple lines of logs, and I need to use some special understanding on how to treat those logs, how to treat those multiple lines. Okay, but we have this application, and let's assume we are logging to the standard output and standard error, and this means that we can use, for example, Docker containers, because Docker containers by default just take the std out and std and manage the and use this for logging purposes. The logs are going somewhere. And how does Docker manage these logs? It uses logging drivers. There are multiple drivers. There are drivers like local, JSON file, and journald, as I've written in here, but also they are like syslog drivers or fluentd drivers, and so on. But there's a difference between them. And if you use the Docker Community Edition, you are able to see the logs locally only using those three drivers: local, JSON file, and journald. That means if you, for example, use the fluentd driver and you want to see the logs, you just type Docker logs and your container name, and you don't see the logs. You need to use the Docker Enterprise Edition to see the logs on your console. If you want to see them, you need to not use the fluentd or syslog or drivers. You just need to use those three. But they are not that bad, actually. And I'd argue that logging into the JSON file is the best we could have. That, of course, depends. But from my experience, I just use this one very much. There is a problem with the logging drivers, and that answers why I use the JSON file logging technique. And that is because logging driver sometimes dies. And if it dies, it can have really bad repercussions for us. For example, we just lose the logs because this logging driver stopped logging, and we don't know about it, and we even don't know about it. Also, there is a problem if we log using the driver into some remote logging as a service. This logging as a services, logging services, they do die as well. And if our logging driver does not know that, we just don't have logs again. And that's why I like the JSON file logging driver, because I can log my things locally. This is going to the file on the system, on the host, and then I can get those logs and put them into my remote logging service. And this way I have them both locally and remotely. And that is done in the way that Docker just stores the logs as a JSON log file, which looks like this. This is log, which is decorated. We have this log, which is the first line. Then we have the stream, which is standard output, and the time of the log. And as you can see, this log, this JSON, this is both structured and unstructured log, because the log itself is not structured, it's just a simple string, but the whole log that we get, the whole JSON is structured because we have this log, stream, and time. And we can take this log and just put it somewhere else, right? Just simply some remote location. And that was all easy, right? If we had local machines, then it was working. Then the Docker came, but it's still some argue this is not the best thing on earth, but I like it. You can use Docker and it works. You can run your programs and have some nice setup on your server. But come on, this is unbearable, right? It just works, and just we need to have some adrenaline. We need to break things. So we cluster things, right? We run them multiple times on multiple hosts, and that is fine, right? We like when it's burning. So here comes the Kubernetes logging, because people get complicated when we run things on Kubernetes. The default behavior for the Kubernetes logging is like we have a pod which should log things into the standard output and error, and this log is grabbed by Kubernetes and just stored on the file locally on the host, and then Kubernetes takes care of the rotating those logs and so on. It is easy. This is good because we have logs. They are available through the kubectl logs command. We just type kubectl logs my pod, and I see the logs of the pod. They are available locally on the node. So in case anything happens, I can just SSH into the node and see the logs in there. But this is of course careful, but this is not really convenient. And why is that? Because first of all, on the node I have multiple pods. So I just, if I want to see things from multiple pods, I just need to, I don't know, maybe run multiple terminals. I don't know, grab through multiple kubectl logs commands. And the other thing is that I have multiple pods, but also I have multiple servers, and they have also multiple pods. So I just need to, have like multiple monitors to see all of them, and then try to grab through all of those monitors. This is impossible, of course. I'm just making a joke. There are some better things to do, and they are called cluster level logging architectures. There are a couple of them, and we are just go through all of them to see how it's going. First of all, we can log from the application directly. As I said at the beginning, we just have our application. It uses some libraries, and the logs are going to the logging bucket. That is fairly easy, right? But this is not that good, because first of all, it depends on the available libraries. And if you have multiple languages and then we have multiple available libraries, things get complicated sometimes. This is good when they work, but it's not when they don't. This is not 12-factor compliant, as I said at the beginning, but this works for multi-line logs, of course. The thing that is not really good about them is that the logs are not available through the kubectl logs anymore, because we just don't stream anything into this standard output. And the logs are not available on the node as well, because we, again, don't stream into the standard output. So I don't prefer this logging technique. There's a sidecar container with a logging agent, and this is more or less the same as before, but sometimes we have this problem that our application cannot log into the standard output. And what to do with that? What to do with this problem? We just can use the logging agent. This is a sidecar container. We just run another container in the pod, which is just grabbing logs from the file, and it streams them into its standard output and standard error, or into the logging bucket. In here, we just use the logging bucket. Is it a problem? Is there a problem here? There are the same problems as with logging directly from the application, because the logs are not available through the kubectl logs. But also we have problem with the multi-line logs, because first our application log into the file, and then another application just read the file line by line and stream the logs into some remote location. And there's also another question about the rotating the files, because this is not shown here on this image, but somewhere between the application container and the logging agent, there is a file. There is a hidden file with a log, and someone has to take care of the rotating the file, because Kubernetes does not know anything about it. So it's either application container or the logging agent. Someone must take care of it, because otherwise our pod will be huge sometimes. Another technique is much better, I'd say. This is logging with node agent, and it means that our application just logs things into the standard output and standard error. The logs are going to the file on the system. Then Kubernetes can take care of the rotating files, but we have another thing which is called the logging agent pod. And this logging agent pod is running on every node of our Kubernetes cluster, and it takes care of the grabbing all of the logs files from all of the containers and pushing those logs into the logging bucket. This creates multiple things, both good and bad. First of all, the logs are still available through the kubectl logs command, because the logs are going just into the standard output. But there is a problem with the multi-line logs, because again we have a file somewhere on the system. But I wouldn't say that those are the biggest problems on our Kubernetes cluster if we want to log things. And I'd say this is pretty good technique to use. Another one is also very similar to the one before, with the only difference is that in the pod we have the streaming container again, which means application again streams into the file, and then streaming container just takes the files, stream into its standard output and standard error. This goes outside of the pod, goes into the on the disk of the node. We have this rotating things by Kubernetes, and again we have the logging agent, which just grabs all of the log files and push them into the logging bucket. This is a really nice architecture, because the logging agent does not need to know whether application can log, into the standard error by its own, or it cannot. It just, grabs the files from the Kubernetes host. So So this is, as I said, the node agent scenario with some simple changes, but we can use multiple sidecars for multiple files, because sometimes it is just like that. We have application, it logs into a couple of files, and we just want to grab logs from all of those files. So we just run multiple sidecars. But there is a problem. There's a problem with the two log files inside and outside the pod. And if you see on this image, we have the log file log, which is rotated by the Kubernetes, but we have this log file which is hidden between application container and the streaming container. It's not shown on this image, but it is there. So we have our logs twice on the system, and that means we need to be sure we do not log too many things, because otherwise we will just run out of space quickly. And let me show you. This is a example for the multiple sidecar containers. First of all, we have this container. We have this pod which logs into the var log path, and we have the same volume attached to two another containers. One of them is Snowflake log 1, another one is Snowflake log 2. They use the same mount volume, and what those sidecars do is they just tail the log files and stream into the standard output, and that's it. We just have we just have the work done. We have our logs stored on the disk, but Kubernetes can take care of them and push them if in its preferred way. And we still can see those logs using the kubectl logs command. Here's an example for the two of the pods, and those logs are again taken by the logging agent and just streamed somewhere else into the logging bucket of our that we chose, and that's it. So the question is how to log things, because there are many choices, and of course that depends on the use case, because all of those use cases are okay. Sometimes they do a job and that's it. But if you struggle with that, I'd say we should not use this tool. If we can avoid them, we just should. And we should not expose logs directly from the application to the logging backend, or using some logging agent inside the pod and put logs into the logging backend, because as I said, we lose we lose logs from our Kubernetes, and that is not entirely a good thing. The streaming sidecar container is good if we must use it. So if we must, then just do it. But the best approach is the node level logging agent. We have this node level logging agent on every pod, and it just grabs the log files, and that's it. So if you wonder how to log things, and you can choose how to do it, then I'd say this is the best you can do. The good part about that is that the node agent logging solutions, that they are there. You just can use what's out on GitHub, and FluentD, of course, is your friend here. It's it's under the Cloud Native Computing Foundation, like the Kubernetes itself, and you just plug and play. It's ready. You just go into the FluentD Kubernetes daemon set GitHub account, and actually this is ready to go. It's recommended by the Kubernetes official documentation, not official, and it's battle tested, because people use that solution and it works. And why is that? It uses the daemon set from the Kubernetes itself, So the daemon set is a kind that runs on every node, and we know that it will be run only once per for a node, and this is really good because this way we won't have our logs streamed somewhere else multiple times from the same node. It will be only once done. And you can use the Fluentd Kubernetes daemon set just to forward. There are a couple of them actually, a couple of those solutions. One of them is forward. It just forwards from Fluent into another Fluentd. And it does that using the var log from the Docker host. It has mounted the valid Docker containers and the var log, but this is from the host. So it doesn't use the logs from the containers. It uses logs that are stored on the Kubernetes node, and then it just push those logs wherever we choose. So it can be remotely, it can be locally. Okay, so there is a question about logging. Should we log everything? Because Kubernetes is a lot of logs, and the answer is not easy. This is not cheap. Why this is not cheap? Because we use Kubernetes, right? And the Kubernetes means that we have multiple logs, we have multiple nodes, and we can scale up things really easily. We don't use it because it's fancy, right? So we just have multiple log messages per second, and that can be much. That can be really many logs. And I'd argue that at a certain scale, it just doesn't have much sense to get all the logs because it really happens if we have an error. We can see after one error that we have it. We don't need to see the same error multiple times in our logs. We should treat it and fix it anyway. Sometimes you just want to throttle your logs, and if you want to throttle, you can use some. There are some solutions for the Fluentd. You just have this plugin throttle, and you can use that. You can say that you don't want some logs multiple times, and that's it. You're good. Okay. So we know how to log things and we know how to throttle them. Let's go into another question: where to store our logs, because there are more. And first thing that comes to my mind, and maybe yours too, is that just go and use the Elastic Stack from Helm. And this is not a bad idea actually. You just can use Helm chart and install, and this will work. This will work on your Kubernetes. But the question is, if you have a really good, really big cluster, whether you want to manage this Elastic Stack, because at first this is easy, but then it is not, and it is not cheap as well. After some time, and sometimes you just don't want to mess with that. You just want to send your logs and then have some nice. Nice things taken out of those logs, and you can use some logging as a service solutions such as LogSense or others. You just send logs, and those services take care of storing and have the search capabilities and so on. And I will be talking now about this, the LogSense, how LogSense does that. So we use the daemon set using the Kubernetes daemon set, and there are like 2 comments. This is fairly easy, and this is not really special for LogSense because this would look the same for another solution that uses the Kubernetes daemon set. So first you need to create a secret. You need to create a LogSense token. This is LogSense specific, and then you just apply your LogSense daemon set definition on your Kubernetes cluster, and it just downloads the Fluentd containers, run them in the pods, start taking your logs, and just push them somewhere else. You don't need to take care of anything else, actually. But as I said, this is not specific to LogSense. If you use your Elasticsearch on premise, you just need to set some things in the daemon set, like address and so on. But it would be fairly easy as well, more or less the same. If you have those logs, they will look like that. These are logs taken by the Kubernetes daemon set from the cluster itself. And let's take a look at this log. First of all, this is our log from the application, which is not that much, right? Not that much. This is a simple string. But because we are running things on Kubernetes, we need to make sure that we know which application has been logging these things. So we need to decorate this log and add some more information. And this is all that. This is an overhead added by the Kubernetes, by the Fluentd daemon set. Those are information that are extremely helpful when you want to debug things and look through your logs from the multiple applications that are run on the multiple servers, multiple Kubernetes nodes. So that is a lot, right? But there is not that much you can do. Of course, you can strip this and tailor this to your use case, but by default it looks like that. But then you can have this nice capabilities of searching through those logs using those metadata. For example, here we see the LogSense screenshot, which can you can look through your logs using the namespace name, or the pod name, or the container name, or the Kubernetes host, or this kind of things. And then you can see the logs from the specific application of your that you want to see, which is really nice. So here we have the logs from the Kafka container. As we can see, there are 3 pods that have this Kafka container, and also those pods. There are 3 pods, but 4 Kubernetes hosts, which means that one of the pod has been moved from one host into the other pod, into the other node. And the last interesting thing on this slide is that we can see the logs level info, and this is nice because we as LogSense we try to get information from our logs and give it to you so that you can search using that. And for example, here we have this log level. And why this is important? It's important because in your log, this was only 4 letters info, right? This was into the that was just in the string, and you could of course use the full text search of Elasticsearch and just type info, and you would get all of the logs that contain the word info. But sometimes you just don't want that. You just want to use the info log level, because, for example, the application could log info. There was a warn with something, and then you have a problem because this log would be shown twice if you look for both info and the warn, but which one is the logs level actually? So we try to get some smart ideas about what was the log level if you don't put it in the first place, and this kind of things. And that's what makes all of those providers different from each other. They are just, there are multiple possibilities about logs parsing and ingestion, and how you can sort logs and so on. Okay, so we have this log, and this log looks like this. We have the metadata, and then we have the log itself. And the log, as I said, is just simple string, some info. It used to be info, but the log is unstructured. The whole log is structured because, as I said before, this is a JSON, but the log itself is not structured, and that creates a problem. That creates a problem because unstructured logs are really good for people to read, but not that good for machines to read. And sometimes we just don't want to read the logs by ourselves. We just want machine to parse the logs and get the relevant information that we want to see. And LogSense can help you in here. For example, here we have the process buffers string, which comes from the Kafka 2 pod. And as you can see, we created the log pattern. This log pattern has not been created up front. We just don't know anything about the log patterns before you put the logs. The log pattern has been created after the logs has been pushed into the system. And once we know that this is a pattern, we can say that, okay, so whenever I see the processed buffers and then some integer, I know that this is integer, and I can do some cool stuff with it. For example, I can create charts from this, and this is really cool feature because sometimes, of course, you can create the log patterns upstream, but if you have Kubernetes cluster and you never know what is going to be run on this Kubernetes cluster, because developers just write applications, they have multiple logging styles and so on, and you would need to prepare and adjust your patterns on the fly all over and over again, right? Because and those patterns changes, of course. And if you don't need to do this, you just have the patterns created by you. You just use them, and you don't even need to know about them. And another cool thing about that is that because we created this pattern for you without your knowledge, you just don't need to know that something is going off, but as soon as we create the pattern, we monitor this pattern. So if we see some anomaly with this pattern, like for example, I don't know, here we have this 50 buffers during some times, and then we see a spike like 500 or 1,000, you get an email, because that was an anomaly, and probably you should know about this. And also, if we create those patterns, you can easily look through your logs if you have multiple logs and see what are the logs that are unusual, because the applications are written like, okay, let's log things from here, and then let's log things from somewhere, and many types of logs occurs many times if we look at the log file. But sometimes I just want to filter them out because, okay, I don't want to see the process buffers because it is all over the log file, and I want to see the logs that are not process buffers. So then I say, okay, I just don't want to see the log pattern of this ID, and bam, I just don't see it. I see all the logs that are not within this pattern. And with multiple tries, we can have the view where we can see like multiple logs per day, different logs, which says something important about my application, which is what was the unusual behavior of this application. Because usual behavior is okay to know, but then it just pollute. And then after sometimes I'm interested in the unusual behavior, and I can do I can do it with those automatically created patterns. And if you have this automatically created patterns, then we can run some our anomaly detection models on them and see what was the unusual behavior and show that to you whenever you had a problem. You get an email. And so on. This is nice, and of course, you can see multiple charts and stack them together to see how they fit you. Okay, so at the end, here are some links. This was mostly done using the Kubernetes IO documentation, which is really good. And the really nice thing about this presentation is that during creating that, while I was creating that, I needed to alter one image and just created a PR for the Kubernetes IO documentation, and it's there in the wild. So I'm very proud of it. But here in the documentation, you can see the image before it was put in the official docs. You have Docker logging documentation, 12-factor net, not only logs, but the whole 12-factor net is good thing, and the link for LogSense.com that we use, that we create and share knowledge about it. Okay, here's the link for the presentation. Thank you very much. And if we have any questions, then I'm happy to answer them. So let's get back to Eliza, I'd say.
Hello, I don't see any questions actually. So there's nothing in the chat. So I don't know. Do you have any questions? I don't see anyone responding. I think everything is clear. Do you want to add something, Marcin?
I just want to thank you guys for listening to this talk, and you can always reach to me using email or Twitter or this kind of things. I'm really happy to help, and always happy to talk about some cool stuff about logging and Kubernetes and so on. And again, thanks for watching.
Okay, thank you everyone for today, and stay tuned for next events. Bye.
Thanks. Bye-bye.